Hello once more, welcome to Z Lessons. In today's video, we are going to look at second theorem 4. This theorem states that a diameter bisects a chord at right angles, and by right angles, what they simply mean is at a 90-degree angle. Just by looking at this long vertical horizontal line, you can see that this is the diameter because it passes through the center of this circle. And as you can see, it cuts or bisects this segment, this horizontal line here, in half, okay, at a 90-degree angle. So that's what they mean by that statement. So this is the conclusion. They're saying that so any chord which is a perpendicular bisector of another must be a diameter. By this, what they mean is that the diameter is also a chord. So if we have two chords and one bisects the other, that means that the one bisecting the other chord must be the diameter. Okay, let us create our circle. So this is our circle like so. So now that we have created a circle, let us add a chord. Okay, so this is our chord right here. Let me just color it so that it's easy for you to see that this is a chord. So that's the chord right there. What the theorem stated was that, let me recap a bit. Any chord which is a perpendicular bisector of another must be a diameter. So what that statement means is that when a chord bisects another chord perpendicularly, that means that that chord is the diameter. So let us go here under construction and let us just click our chord. So what this will do is that it will find the perpendicular bisector of this chord. As you can see, when I click it, as you can see what has happened. So what this means is that this chord, this red chord here, has been perpendicularly bisected by this line. And as you can see, this line passes through the center. And we know that the line that passes through the center is only the diameter. So which means the diameter is the only line that can bisect another chord perpendicularly. So that's what I mean. So let us just make sure that we have a perpendicular bisection. By bisect, we mean that we need to cut this chord, this red chord, in half. So I'm going to measure the distance from DE and the distance from EC. If the distance is the same, that will mean that we have a perpendicular bisection. Let me just do this. Okay, as you can see, DE is equal to 3.9 units. So let us see if EC is also 3.9 units, as you can see. So this means that this chord has been bisected perpendicularly. Okay, so therefore this diameter right here, that is this line or this chord that is passing through the center, has bisected this red line in half. So that's it. If we want to prove it further, we can add another chord. Let's add another chord like so. So that's our chord, and I'm going to color it in a blue color. So now let us find the perpendicular bisector of this chord right there. So we get our tool and we click it, and as you can see, it is passing through the center. So this means, my friend, that the diameter is the only chord that can perpendicularly bisect another chord. So that's your proof right there. So that's what's happening. That's essentially what's happening. As you can see, no matter how many times I move it, let me just get rid of it since we are done with that. No matter how many times As you can see, no matter how many times I move it, the line that can only bisect this red chord is the diameter. As you can see, that's the line, the only line that passes through the center of the circle. So there you have it. I mean, you can see that this is a perpendicular, but let us just measure it real quick. Let us measure the angle so that you can see that this is the perpendicular bisector. It's going to form a 90 degrees, as you can see. Let us also measure this end of our chord, and as you can see, it's forming a 90 degrees. So that's what the theorem means. When a chord, any chord bisects another chord, that means that that chord is the diameter. So as you can see, the diameter is the perpendicular bisector, as you can see. There you have it. So let me show you a scenario of how a question might come in the exam. Maybe they won't show that. Let me just delete that. And what can I do? Let me just delete that. In the exam, they might say that state why line GH is the diameter. So in this instance, what you would say is that GH is the diameter because it is the perpendicular bisector of CD. So that means that you are applying the theorem to answer that exam questions. And as you can see, it's the perpendicular bisector of this red line right here. So there you have it. Thank you so much. If you're new to this channel, I would encourage you to subscribe because you are not going to miss out on the videos that we create in the future. Remember to like this video if you liked it, subscribe, share to your friends, your family, and I'll see you very soon. Have a nice day.